Hello and welcome to my UAV security research series here at the Aerospace Village. This is episode 3. In the first 2 episodes, we went through an introduction to UAVs, the type of things that UAVs are being used for today, their composition, what's going on around the world in terms of UAVs, and what's going to be happening in the future, potentially. In episode 2, we started the build, starting on the airframe, and getting the physical aspects of the drone together. And in this episode, we're going to be talking about or covering the electronics side of the build. But first of all, so the topics we're going to be going through today, I'm going to give you a little bit of an update on some of the topics we touched on in the first episode, because there's been some movement there. I'll give you a sit rep on where I am with the parts, go through the servos, ESCs and motors, attaching them to the wings. We'll talk a bit about the flight controller and then show you how I've fitted and wired up the whole thing. And then we'll finish with a little bit of a wrap up.
Firstly, a few updates from the industry. So there's been some really exciting stuff in what has been barely 2 months of this year. The first one is Skyports. Now, if you think back to episode 1, we talked about how they did a trial of delivering COVID tests and PPE between basically a remote medical facility, a remote hospital, and the mainland. Well, now they're starting up an official delivery service for the NHS. This is huge news. So this is going to be scheduled and ad hoc deliveries between medical facilities in the Argyll and Bute area in Scotland. For those of you who don't know, Argyll and Bute, it's highlands, it's islands, it's remote communities, and they are quite isolated when it comes to the mainland. They really do live in a bit of a bubble. The drones they've got authorization to use, they're 3 kilogram payload up to 40 miles, and that's pretty impressive, I must admit. And like I said, it's going to be used for COVID tests, medicine, and essential PPE. So I think what we can see from that is it's going to be, the test kits and the samples coming back, possibly vaccines, I'm not sure, but most likely non-temperature dependent medicine, and then PPE such as masks and what have you. And the key thing is that the journey time between these 2 points is going to be cut from hours down to just 15 minutes. That is a huge difference. When you think about it, you've got roads which don't go point to point, and you've got a ferry, you've got sea in the middle. So these journey times are really a game changer. If you think about the fact we can't travel very much at the moment. If you have to go from a remote island to the mainland to get a test and then a result done, then you are potentially spreading more virus. So brilliant. Let's fly the necessary tests to a medical facility near you, and then fly the sample back for the results, which you'll get either through email or text message or phone call from your medical provider. So this is a real shake-up of remote medical medicine here in the UK. And I wonder how much of a influence the work that's been done in Africa has been to this. I hope one day we can get Skyports on here on an episode. It's not going to happen probably this side of DEF CON, but I hope after DEF CON we can start getting some of these operators on this series, and we can start talking to them about their services, their influences, where they're learning from, and of course the regulations and the cybersecurity that goes in there. So, watch this space. I'm going to try and get them on here, but I do have some other exciting news, and that is CAP 722. So those of you here in the UK who have been paying attention and keep their their ear to the ground when it comes to flight regulations will notice that CAP 722 was released late last year, and it is now in force. So it came into force on the 1st of January here in the UK, and it's new regulations for all unmanned aerial systems here in the UK. And when I say all, I mean all. So recreational and commercial, UAS, UAV drones all come under CAP 722 now. And it's a really exciting piece of legislation because they've really, taken the current situation, distilled the risk, and defined categories of both drone and types of flight, and what can be done with both, and what you need to do to be able to do things above those categories. So whereas before, your recreational UAVs had to follow the drone code and were pretty much restricted to that. Now all drones come under this CAP 722, so the possibility of getting certification is now open up to recreational drone flyers. Now, that's a really interesting concept. So it basically puts everyone in the same bucket, and is really based on risk, which is a really refreshing view, really, to be seen at the regulator level. And I think it's probably the most forward-thinking of all of the regulators I'm seeing in this space at the moment, and I include, I'm sorry to say it, guys, the FAA in this. This is a really groundbreaking piece of work that's been done by the CAA, and there's a big section in it about cybersecurity. So, episode 4, as you know, will be about regulations, and I've got some exciting news. I've been speaking to the CAA, and they have agreed to come on and be a part of the next episode. So I'm going to be talking to them about CAP 722. I'm going to be talking about what what it means for us, and get some more flesh on the bones. But also, I'm going to have some Q&A. So I've got a bunch of questions I want to ask them about it, because I've got my own drone that I'm building. What can I do with it? How far can I go realistically? Can I get extended visual line of sight, or even beyond visual line of sight authorization? Is that within the realm of the possible? And if so, what do I need to do? But if you have any questions, send them in, because they've agreed to also take Q&A from the public as well. But you need to send them in. Send them in to either my Twitter at CyberGaffers, to the village through the Discord channels. You can either send it in the channel or in a DM, or you can email it to the village as well. You go on our website, which is www.aerospacevillage.org, and there is a contact section on there. Send it through. We'll pick the best questions, and they will be presented to the CAA in episode 4. So really exciting, and I'm really thankful to the CAA for agreeing to be a part of that. So anyway, moving on. So, Believer, I've had a bit of a problem. So I ordered a bunch of electronic parts in the post from China. In retrospect, that was a mistake, not because they're from China, but over Christmas we had COVID-affected deliveries. We had the increased demand due to COVID over Christmas, so people sending things through the post, and we had Brexit as well. So I think all those three things combined, the package was, I was tracking it online. It didn't move for months. It kind of bounced around Europe. It went from Belgium to Spain, back to Belgium, then to Germany, and then sat in Germany for a month. And I was like, well, forget it. It's lost. So I went ahead and through a number of local drone shops, I've ordered some parts. And then, annoyingly, the package from Germany just arrived. It just literally changed status overnight. It landed in the UK. Within 4 hours, it was at my house, which was a bit frustrating. So I've had to, send that back because I'd already ordered all the parts from, various places here in the UK. And I'm going to give a quick shout out. we try and stay agnostic here in the aerospace village. We don't give favoritism here, but I've got to say that 3DXR, based up in the northeast of England here, they have been a huge help to me, not just in my understanding of the flight controller, but I kind of messed up a cable, and I tried to buy a new one. Something didn't work on the website, and they just sent me sent it to me in the post, which was extremely nice of them. If you're here in the UK or Europe, they deliver to Europe as well. Go to 3dxr.co.uk. Excellent website, very helpful guys, and they work a lot with another guy who does a drone series, and they actually figure in his videos about how to set things up. So extremely helpful. Moving on to the parts. So I'd originally gone with a kind of generic Pixhawk flight controller, and I thought, you know what, Cap 722 is coming in. If I'm going to be taken seriously, I need a flight controller that means business. So I went for the Pixhawk Cube Orange, and the really interesting thing about that is it's got a tiny little aerial on it, and it's got an ADS-B in. So it can receive ADS-B signals, and you can configure the flight controller to react based on those signals, which is a really interesting concept for a flight controller that's within reach of the recreational flyer like myself. I also decided to go, go heavy on the GPS unit. So for Ep3 GNSS, it's an extremely accurate GPS system, and it also allows RTK as well, which means that based on the known location of the base station, it can basically produce positioning down to the centimeter, which is really good actually. It's not quite at the top of the range, but the top of the range costs over £1,000. But the Ep3 is certainly no cheapy GPS unit. It means the business. Also for accuracy of airspeed, I've decided to go with a digital airspeed sensor from Maytech. And for the telemetry, got to stay legal. So the frequencies in use here in the UK are licensed as open category, 433 megahertz at 100 milliwatts. That's as far as I can go. So I've gone with the Holobro telemetry. I'll talk more about that later. I've had some issues with it. They were my fault, got the wrong drivers, but I'll talk about that later. And then the Emax ES3 3054 servos. The reason for those is they fit perfectly, and I'll show you later. They fit perfectly in the little slots in the boxes that come with the Believer. I believe other servos you'd have to kind of machine the parts, or you can print your own little box with a 3D printer. These fit perfectly. They're metal geared. And they are very heavy duty, not the heaviest duty, but they're very heavy duty for a drone like this. So they are more than suitable for the job. The motors, so I've gone for the T-Motor 2814. That refers to the size, the 900 kilovolt. 900 kV. That refers to the number of turns that are on the coil in the motor, and that determines the speed and the power it uses as well. Now, according to the charts, this motor, coupled with the 12-inch props, the 12x6 pitch, produces a very efficient combination. So in terms of thrust for watt, and in terms of thrust in terms of low wattage as well as the temperature that's going to be going through the motors as a result of that combination, are all really ideal. So that's the reason I've gone with those. That said, 12-inch props on this plane are very big. So you might want to think about 10-inch props if you're doing the same aircraft. But then you probably need a different motor, a different KV. to supply the motors, I've got 2 Hobbywing 40 amp ESCs. You know, they're brilliant. They're really doing the job. And because the Pixhawk Cube Orange has a dual power input, I've gone with 2 power modules, 2 hex power modules, and these are wired separately from the battery. And I'm also probably going to get, you see that I've got you know, a 6S 3P lithium ion battery block, you know, a big lump of battery. Well, it looks tiny in the battery space. I'll show you later. I can fit a second one in there, no problem. So I'm going to get a second battery, and then have you know, both batteries in parallel with dual wiring to the power modules, which both feed the flight controller and the servos and everything else. So if I get one battery which fails, the other battery will take up the slack. If I get a wire that kind of frays and doesn't quite make a decent circuit, well, other wiring will take over. So, you know, it's all about having redundancy in there, and making sure that if there is a failure in one of the parts, it's going to have other means by which, and other systems which can take over. Going back to the flight controller, the Cube is also has redundancy built in. It's got you know, I've got a compass in there. I've got a compass in the GPS. There are barometers. There are different IMUs. There's about, I think, 2 or even 3 IMUs which are heated for extra accuracy. So what I'm getting at is, you know, apart from the airspeed sensor, which is kind of you know, a complement to the speed that the GPS system will be showing, you know, there's no system which doesn't have redundancy. I am going to get a second GPS unit. I'm not sure if I'm going to go with another Ep3, or if I'm just going to get a different GPS unit and then mix the results, which you can do in ArduPilot. But I still haven't decided on that yet. But basically, what I will end up with is, you know, a highly redundant drone system, which should, I'm hoping, you know, be a positive thing when it comes to looking at getting some extra authorizations under CAP 722. And then right at the bottom there, I've got some UBECs, and I've got 3 separate ones doing 3 separate jobs. One's doing lights, one's doing the servos, and I've got another one doing the ESCs. The reason for 3 is because they produce a little bit of RF in them. They do have a magnetic coil which reduces that, but it's still not perfect. So in order to reduce any kind of interference on those lines, I've split them out. And I also found actually initially that I had them all on the same UBEC, which normally should have been enough because it's 3 amps with a surge of 5 amps capacity. What I was finding was when the servos go to the extremity, they draw on a lot more motor power to try and go further, but obviously they're being stopped physically. And the power draw when that happens is huge. And what I was getting was brownouts, and that was causing problems. So I've split them out. I've split the pain between 3 different UBECs. The lights as well, they're very low wattage, really. But when they do fire, and they cause a drop on that voltage rail. So I've kept them separate from everything else just to make sure there's no problems and interference with those systems. And then, of course, it wouldn't be a decent drone without a camera system. So I've fitted a couple of cameras. Again, I'll show you later. I've done what I think is a pretty decent job. I've got one facing forwards, one facing rearwards, because who doesn't like a shot from behind? And I've got a Wi-Fi cam switcher, which is set up on one of the channels on the receiver. I can flip between the 2. And that comes back through a video transmitter, which again has its own UBEC because it's 12 volts, not 5. In total I've got 4 UBECs on board. Doesn't matter, there's loads of space inside. You know, that I'll show you all the wiring later on. Now, an optional thing I've gone for as well, I don't really want to belly land my drone because, you know, I've got really big propellers, and I don't know, I would rather, you know, just drop a parachute. So that's what I've gone for. I got an 8-foot parachute. It is a really tight fit in that bay, but I think it will work. I think as long as I pack it right, I can get it working. And for that, you need a micro servo as well. That's not the same size as the ES3054. They are smaller, yeah, the micro servo just fits perfectly in that space, which I made for that hatch. And in terms of sundries as well, you know, I've gone for twisted servo cables. Again, I'm reducing interference on the lines. Because I'm using my own cables, well, you know, I need to make my own 3-pin connectors for the servos. So that requires special tools. You can get it all online. I've got a link to all of this actually on the video, and it links to a page on the Aerospace Village website, which gives you all of the a list of all of the episodes, but it also gives you the a list of all the parts as well. So I've got cable clips and organizers because you've got a lot of wiring going about. You don't want it flying around. You don't want it interfering with things. Plus, I want to keep things to the sides and have that payload area nice and clear for when I want to use it. Xt60 connectors, so large batteries use these, and basically they're a really good idea to put in place along your line as well, so you can swap parts out and disconnect parts of the circuit when you need to test certain parts. So I've got a few of those in there. Bullet connectors, I think these are, you know, absolutely brilliant. You know, really cheap, but really effective in terms of just giving you single wire connectors, basically, which I've used in the wings for the ESCs, and I've used in the body as well, just to be able to, like I said, disconnect and isolate parts of the circuit when I want to. But when they're connected, there's no chance of them coming apart, so it's really, really good. Now, there was some 16 AWG silicon cable in the pack with the drone, but I've used more, so I've got a couple extra meters, red, black as well. And I've got lots of electrical tape and cable ties in there as well. Tools-wise, don't go cheap on the digital soldering station. Get a good one. You need decent tips on there. You need to be able to configure the temperature of the soldering iron, because if you go too hot with some of the plugs, you're going to melt the plastic. So you need to go with a really low temperature there. But there's other parts where you've got large, you know, large amounts of solder and large amounts of metal in contact with it. You're going to have to bump up the power again for that. So you need a digital soldering station where you control the temperature of the you know, of the soldering iron. And of course, for the heat shrink as well, you're going to need some kind of hot air element to it as well. And most decent soldering stations have those attached to them. You could use a hairdryer, but you know, not all lads will have one. I know some guys do have hairdryers, but you know, without being sexist or misogynist, it is mostly women who have this. And if you're using your wife's or girlfriend's hairdryer to shrink wires, you probably aren't going to last long in your relationship. So, you know, do yourself a favor, get yourself a soldering station with a digital soldering iron with temperature controllable tips and the airflow as well. Also, you know, you're going to run out of hands. You need decent soldering clamp as well. And if your vision is anything like mine, you're going to need a magnifying visor. Some of these wires are really small, and you know, while I probably could have soldiered through and done it without, having the visor just makes a massive difference. Makes it so much easier and clearer to work on. So you know, that's my advice for that bit. And that's you know, that's enough waffling from me right now. Let's get on to the next part. Let's show you the servos and motors and ESCs being attached to the wings. But what I have been doing is making progress on fitting electronics. So as we can see here, I have a wing that is ready. I've got, underneath this panel here, you've got the ESC wired in. You've got the motor fitted there. It's all wired up, soldered up. All the connections are tested. The servo's in and connected to the flight surface, and it's kind of tuned to about the right spot. I'm sure I can play with that into software later. But basically, that's one wing ready. So what we'll do today is we will do the other wing and fit the tail servos for the tail plane, and we might even do some playing around with the Pixhawk. So here's the kind of bare wing. So the servos they recommend for this are the Emax. Which ones are they? Emax ES3054, and the reason for that is they're compact, but they're also metal geared, and they fit perfectly in this little box here, and they do fit really well. They come with a few bits and bobs. Bit disappointed it didn't come with the single arm that you kind of need for aircraft in this situation. So I just modified this and made myself that. If you can see that very well. Where's the black? Where's the contrast? There we go. That's what comes in the box. That's what I did. I just trimmed 3 of the arms off, and now I've got a one which will move about nice and freely. So I stick that about halfway. The pack comes with a bunch of screws and these kind of rubber pieces there, which would normally fit on here and just add a bit of vibration dampening. But the design of this aircraft was such that you don't use those. And then you're going to fit this in a way, as we can see on the other wing. So the arm is pointing out towards the outside of the wingtip. So we're going to replicate that in here. So servo goes in that way. And I don't think you can see it here, there's too much light, but there's a little channel here for the cable to go down. So I'm just going to the M2 by 8 screws again, the self-tapping ones rather than the threaded ones. Well, the few problems with having big hands is handling tiny screws. So this bar goes over the top of the servo, and these just bolt in, I believe. It says these are M2 by 10. I don't believe that, because these are significantly slimmer. So one thing to note is that the lugs on this bar do not sit absolutely flush with the box, and the reason for that is to allow you to put pressure down on the box, so on the servo, so it doesn't move. If it was flush, the servo would kind of vibrate in there and cause problems. So when you're doing one side, don't do it too much. Just get a few turns in until it's in the right place, and then make sure it's all square. One thing I have noticed with these is some of the pilot holes for these are very easy to strip. So you don't want to go too strong with the torque there, otherwise you'll find that the screw will pop out at some point. If you do find that you've threaded one, what I would do is I would just pop a bit of glue in there, put the screw in loosely, and then wait for it to fully cure and just give it a half turn or a turn just to torque it down a little bit, and that would be good enough, I reckon. So that's the servo in. So now control arm. So just looking back, so I've got uniformity. So on this one, we have the control arm to the inside on the servo and the outside on the control surface. So inside on the servo, outside on the control surface. So it's going to be like that. Like I said, inside on the servo arm, outside on the control surface. Yes, so the arms on that, the supplied nut and bolt don't fit. So we shall give it a little encouragement. So I've grabbed which one is this? Number 1 screw head. And I'm just going to use that to just make that hole a tiny bit bigger. And then for the nut, you need a 4mm socket. And I'm using the uppermost hole on the control surface there. And I'll just get it finger tight. Nothing too much. So it's a nylon nut. So once it's on past the end of the thread, it's not going anywhere. Okay, so that's the control arm sorted out. Got might need a bit of tuning. I think once it's in the middle there, I'm a little bit too far forward, but that's easy to sort out. I just take one of these off and just turn it until it's right, but I'll do that later. I'll bore you with that now. What I do have is some pre-prepared ESCs. So these came with much longer cables attached. These are the original power cables, but I shortened them, and I've added some fittings on there, and I'll put the sizes, make it visible for you. It's got the ESC here. Except the cables are much longer. I cut these down for a reason. So, and I added these plugs in. I could have just soldered it straight through, but I've decided what I want to be able to do is to, because the design needs to be modular, that stuff needs to be able to be taken out and replaced or swapped out or borrowed even between airframes. No guarantee it's going to be only one. Shh, don't tell the wife. So yeah, so I shortened the control cables down because they were massive. They were about this long, and I shortened these down to a suitable length. Got the same on the other side as well, and then the other part is in my soldering clamp. So, and I pre-soldered this because A, it just takes so long, and B, I don't need to see how bad at soldering I am. But essentially what this allows me to do is that channel underneath here is big enough. I can just fit that in, fit that to the end, and then this all just plugs up and connects to that. So what I used here was 2 of the servo cables with a female end, and then I use these, which just kind of push and pull apart. These are really good, especially when you've got high current going through. So we'll just fit these now. So the way I've done mine is my longer one is for the ESC and the shorter one is for the servo. And that's just deliberate. Just make sure that's the right way up. Obviously the servo one doesn't need to be that long, so keep it nice and short. Make sure it's brown to brown, yellow to yellow. Yep. So that goes like that. And that can just be tucked neatly out of the way. And then for the ESC, so I'm just going to have to make a note of which way these are. And they do only go one way because there's a groove. It's not that noticeable, but there is a groove. And these just connect up. Also, I've got heat shrink on here to ensure that they don't short out, but I'll also add a little bit of insulation tape eventually, just to double make sure there's no shortage of those points, because that would be a really bad day. And here's the motors. So this is the recommended motor, which is the T-Motor AS2814. And what that refers to, the 28 is the diameter of the motor. It looks a bit wider than 28 mils, but that's what I've been told. And 14 is the depth. Again, it looks a bit bigger than that. But that's what the numbers tell me. If you know better, let me know, because like I said, this is I'm not an expert at this. This is my learning curve as much as it is yours. So if I remember rightly, we have the motor mounts fitted at the front here, and made sure that the plates were orientated. So there's some metal fittings and they were on the back facing towards the wings, so they're facing this way. And that's so that this bracket, which you screw onto the back of the motor, you can see there's 4 screws. You screw that onto the back of the motor, use a little bit of Loctite, or some thread compound, because the vibrations could release these a little bit. And then do the same again with the bolts that go through here. Now, I don't have the bolts yet. They weren't included in the kit. I didn't have anything suitable, so I'm waiting for them to arrive. They should be here tomorrow morning. But I believe it's either an M2.5 or an M3 bolt. 8mm should do it, maybe 10. Again, just a little bit of thread compound through there into the mounting plate. But there's so little tolerance in here that actually, when you just push fit these in, they sit rather stably. So I'm just going to fit that now. Orientation right. 1, 2, and 3. So follow your instructions for the ESC. Just make sure that all of your wiring is correct. It also goes through the procedures on how to kind of learn the ESC as well. So when you put it into learning mode and you give it full throttle, low throttle, it then understands the range of throttle input it's going to get from the controller or from your flight controller. And then it adjusts accordingly. So it knows what 100% is supposed to be, rather than what the factory offset might say it is. So you don't get a situation where you're not getting, the full juice out of your motors, which if you're in a, maximum takeoff weight scenario, that could be quite bad. So, and then that plate, that goes on here. I'm not going to do that now. I have noticed on the other wing where I did fit this, that, these threads aren't great. So I'm just going to do it the once on this side. But yeah, basically, this is a tight fit. It does fit, but the tolerances are square root of 0, pretty much, which is pretty impressive when you consider this is all foam and probably pre-built. When you push fit that, there's very little of a lip there. What you do find sometimes, depending on the way your wires are, they might push out slightly and you get a bit of a 1mm bulge in the middle here, which is probably something I might look at later, because you can buy these kind of screw eyes here. And what I might do is I might fit some in the middle there just to prevent that bulge from happening, just to make it a little bit more aerodynamic. So the last thing to do is to fit the screws on the end here. So just put that to one side. And you can feel a noticeable change in weight now. The ESC isn't too heavy. The motors, the servo is quite light, but that motor's heavy. That is a heavy beast. So if you're going to spend some time in making sure that you've got thread compound and making sure it's properly torqued on, that's where I would definitely spend the time, because that is obviously an area of potential failure, I would think, just going off of experience. And so Archangel, the guy whose thread that switched me onto the Believer, he made this awesome thread on rcgroups.com with a full build and test flight series, and other people got involved as well. He had an issue whereby when he was giving it the beans and going full throttle, that his motor was, I think, slightly offset, and I wonder if it was because the screws came loose or something. something happened and his motor was slightly pointed down. At cruise speed, it wasn't too much of an issue. When he gave it the beans, it was enough of an offset to cause the aircraft to actually nosedive slightly. Yeah, absolutely make sure you get that right. So. Actually, what I was saying about that motor, now these are M3 by 10. Maybe I was wrong. Maybe these are for mounting the motor. Let's have a look. So it could be that the kit does have screws for mounting the motors after all. So we shall try with one. Okay. Yes, they are. So I was wrong. They do have the screws for mounting the motors in the kit. So it's these are M3 by 10 panhead in the kit, and I'm not going to fit them today because I don't have the thread lock with me. But yes, they will all fit. Excellent. So you're having magnetic tips on your screwdriver. Really make this job nice and easy. So there we go. That is the end fitted. I'm not sure if you can see that. There's no light. Bring it into the light there. So there we go. That's that fitted there. You can't fit it the wrong way up. It is cut. The groove is cut the right way. So there we go. That's the wing sorted out. That's the motor mounts, obviously, which I'll do tomorrow when the thread lock comes. And now I'll finish off the tail servo. So I've already kind of fitted one. These are really tricky to get in. Let's go through that right now. And I also used screws which don't seem to hold it in place, or a screw. And the reason being is because that hole is too wide. So let's try and use one of these on the end. So you can see here that I've fitted the tail servo fitting on this one. I'll do that in a second with the starboard side. But yeah, this can only go on one way. You know, there's no, there's only one way of fitting that on for all the holes to align. So if you're putting this on and only 2 of the holes align, you're wrong. Keep going around until you get 4 holes, yeah, then it'll be good. So, and just like I was saying, this is a really kind of tight fit in here. I wonder if we need to use that, because it's weird because there's no lip for it to kind of hold on this end. Or is there? No, there's no lip there. There's no hole for me to screw it into either. And that just fouls on that side. How bizarre. So I can't use the rubber fittings. So it's a really tight fit, and if I put the right screw in there, it's not wide enough, and the servo just pops out. So I do have these from something else. Now, these are the same diameter as the screws I had in. They're a different gauge, but they are pan head, and the pan head is wider than the hole in the servo. So these will stop the servo from coming out if I can get the thread to bite. Annoyingly, these aren't magnetic, so I'm going to have to use some tweezers. Okay, that's going in. Like I said, it's really weird that there's no screw on this side, which, you know, would be difficult anyway, because I'd have to take this the bevel off. And once the wing is on, it's going to push down and hold that in anyway. So you really, you get away with one screw there just to hold it in place whilst the wing is off. So let's go through the side. So now in the pack you get these really tiny screws, and you need 4 for each side. There's 2. 3 and 4. And there's 1 spare in my kit, so they obviously couldn't count. And then we got the top here and the servo. So we shall fit the bevel, which is this one here. Just took it all out. So there we go. So fit the bevel, bolt that down. So when I said there's only one way, so there are 2 90-degree positions this can go in. There are other points where 1 or 2 of the holes line up, and you may think that's okay, but no, just keep going, and eventually you'll get 4 holes lining up. So we should do that. So just like with the motor vehicle wheels, work diagonally, just to ensure that you get an equal amount of pressure on all 4 sides. Again, doesn't have to make it tight, just hand tight will do it. Then I'm going to thread this cable in through that gap, and then we're going to fit this into the space and screw it down with that. Okay.
So get the hatch out. Put that to one side. So there's the cable. Pull that through. Okay. So now that's on. Let's dry fit the wings. Sorry, the tailplane. So, and this is something I recommend you do before you plug these servos in. So you can see these are obviously not attached to anything. They're going to have to get some extenders on there and come to the flight controller at the front here. What you want to do is turn these to align with that now, because when you turn these, you could be generating current, which goes back through here, and you just don't know if that's going to cause any problems. So you're best off doing it now whilst it's disconnected. And you can see that the lug there is kind of 90 degrees to the aircraft, and we'll just fit that on. There we go. Servo down. As I was talking it down, it kind of pushed up this side, so we'll just loosen that off a little bit. There we go. Let's right in. So let's move that light up just so you can see better. There we go. So now we have two wings and the tailplane all set up with servos, motors and ESCs. So now we need to start talking about flight controllers. So also in the kit, along with the servos, were some other goodies. And let's bring these out for you now. So I decided to invest really in a really good flight controller. This is the latest RG Pilot compatible Pixhawk. So interestingly, it's RG Pilot. They teamed up with UAVionics, and they developed this board for it. And obviously, it's still based on the the PX4 base board or interface board with the cube, and that's where all the goodies are. Inside, you've got your your compass and your IMUs. Come on to those in a minute, but you'll see it's got this little wire sticking out here, and that, ladies and gentlemen, is for ADSB in. Yes, this flight controller will receive ADSB traffic from the local area, and you can program it to react to that traffic. And when I was talking earlier about CAP 722, obviously one of the things about beyond visual line of sight is even if you've got a video link between the drone and yourself,
you can't see over your shoulder. You can just see what the camera is showing you. You know, so you can't see left or right of field, and you can't see above you, and you certainly can't see behind you. But if you have ADS-B in, what you can do is say, well, actually, you know, I'm going to fly at 100 meters because that's what the law allows me to do. But as soon as I see traffic coming in within a certain distance, I'm going to do you know, one of several things, and you can program it to dive. You can dive. You can program it to go to a higher flight level. Go into loiter mode, which is basic, just goes around in a circle at a certain height, or even return to base. So another reason I got this this flight controller is because it's got a lot of redundancy built in. And from my work in the aviation field, you know, I was never directly involved in airworthiness. Some of the work I did fit into the airworthiness approval, but I wasn't directly involved in it myself. But you still pick up things, right? So, you know, you know, for example, on you know, passenger aircraft, you've got not just one redundancy, but often two redundancies. You know, so you will have, you know, three hydraulic circuits, all three with independent, you know, pumps and controllers and circuitry. So if one goes down, you know, the other will take up the slack straight away. And this is the same. So the GPS unit that's on the way, that's got another compass and barometer in there. So I've got two compasses, I've got two barometers. You know, the IMUs, there's two in here, and they are heated. So I can fly this in cool temperatures because the IMUs are affected by the cold. They lose accuracy when they get cold. So these are heated, and that means they maintain their accuracy. I can also have two power inputs. So here we have a BEC, which kind of sits in line with the battery. So the battery will plug in this side, and this side will go to the aircraft. I've already got the Xt60 plug in there. But the BEC provides a regulated voltage, 5 volts in this case, to the flight controller. And actually there is a way of wiring it to use two BECs, wired in a certain way, which can then feed a second power here. So it's got two power inputs. So what I can do is, if one of the BECs, wire it up in a way that you've got the two BECs and working together, where if one fails, the other one takes up the slack. And this will all feed into the risk assessment, like I said, for the 722. And the risk assessment, I'll be able to say, well, you know, if I do get catastrophic power failure in the delivery system, I've got a backup, you know. So all these mitigation strategies are coming in. And then we got over here, so I bought a telematics or telemetry unit. So obviously it's got to be legal, so it's 433 megahertz here in the UK, and a maximum of 100 milliwatts, which is not a lot, but you're in line of sight. So, you know, airwave, line of sight, 100 milliwatts, you're going to get a few kilometers out of this. You know, you're not going to get tens of miles, but you're going to get you know, you're probably going to get a couple of miles out of this in line of sight mode. Now, when it comes to longer distances, I've been reading up, and there are some people that have had success with using a Raspberry Pi 3 and a LTE modem attached via USB. And that is then connected to one of the serial ports here on the flight controller and set up. So you can have the telemetry going over both. So it goes out through, signals going in and out through 433 megahertz, but then also over LTE. And the results I've seen have actually been pretty good. The latency is very, very similar to what you get over the radio. So it looked really promising. And it will also provide backup and redundancy. But one thing I've been interested in doing is obviously trying to hack telemetry. So will I be able to sniff the data going between the ground station and the drone, and then replay some of that data, changing the parameters, maybe give it a different flight plan. But then if we have telemetry also going over 4G, there will be a disconnect. And which one will take precedence? I don't know yet. I haven't looked into the software. I haven't tried this out, but we can do some bench tests and see what happens and see what's possible. Because obviously hacking 4G, I don't think we can do that. There are SS7 attacks you can do where you can bring the modem down to 2G or even GPRS, and then you can kind of sniff some of the data. But that's the equipment for that's quite expensive, and also I'm pretty sure it's illegal. So I won't be able to do that either. That will remain theoretical. But at 4G, obviously that's going to be difficult to mess around with. You probably have to be nation state and kind of get in on the backbone of the mobile signal provider, or even try and hack the ground station itself, which is another thing we'll be looking at. Because actually, if it's going over 4G, it's going over IP, and that Raspberry Pi will have an IP address. So we'll be looking at if you just plug a Raspberry Pi straight in, what can you see? What ports are open? I actually know that already because I do a lot of Raspberry Pi work. But we'll look at what can be done to protect that Raspberry Pi as well. So, and these things might be implemented by operators and kind of overlooked. So we'll explore all of that. And then, yes, and I mentioned operators there. There are actually a lot of operators using flight controllers, this flight controller and similar ones to it, for commercial operations. So whereas the intra-airport hydrocarbon engine UAV maybe uses a slightly more expensive commercial flight controller, a lot of the other more basic UAVs that we have will actually use something very similar to this. So this will be pretty close to real life. So it's going to be interesting to see. And then finally, yes, you see me playing around with this. This is a good old pitot tube. There's a few more bits I want to add on to the flight controller. Obviously got the GPS coming very shortly. The pitot tube, that will give me a very accurate airspeed value. It's just a tiny little thing here. These obviously don't come off once they're on because, well, they do, but not very easily. So, I'm going to wire this up into here. And for calibration, you literally just blow on this before we put it in the aircraft. Once in the aircraft and you have it in loiter mode, it'll spin around a few times. And then it will figure out, what's going on, and then it's able to calibrate the speed being picked up by this. And it literally, it's literally like it measures two different pressures. So you probably can't see it on this, but there's some holes on the side here, and then there's a very tiny hole at the front there. And obviously that's going to have a higher pressure than the air's coming in this way. So the pressure inside that hole is going to be higher than the air that's rushing past that hole and actually drawing pressure out, drawing air out. So, and what it does is it measures that differential. So when I got this through the post and I unboxed it, I noticed that the cube wasn't orange, and I thought maybe there was an error. Which was weird because the box said orange, but I opened the box and it was this gold cube instead. So I Googled it, and it turns out that, in the style of Willy Wonka's Chocolate Factory, that this was a bit of a competition. Pre-COVID, they were going to just give out 5 of these. and you know, invite the winners to the drone show last year. Obviously, that wasn't going to happen due to COVID, so they upped it to 100, and so it turns out I win a T-shirt for winning the gold cube, which is amazing. But I also get to tell my story on their socials as well. So if you are watching this because of that that exposure to you know, to RG Pilot, and you're just a drone enthusiast, but you're interested in what we're doing here in the village, welcome. And yeah, it's been
So now we have our parts and we have our flight controller, and now we need to start plugging everything together. So this is how I'm going to be doing it for the Believer drone. So I have give me a pointer here. So here we have the flight controller in the middle. We have the battery over here, which supplies the two power modules. These are known as hex power bricks. Not cheap, but you don't want to really skimp out on this part. And then on a common rail, they then feed the BECs, which then feed different parts of the system. This one here feeds the Cree strobe-on lights. The next one actually feeds separate power to the servos. And then the last one serves power to the ESCs. Now there's two that go into the ESCs. There's one from the BEC, and then there's a direct feed from the battery, and that feeds the actual motors as well. So there's one for the signal line and then one for the motor power line. Very different power requirements. This is the straight 6S battery power going through here, whereas this is 5 volts. So massive difference there. You don't want to mess them up. You will start screwing and destroying equipment. So moving on as well. So we have our telemetry module, like I showed you in the video. That is connected to telemetry 1. Connected to the IC2, we have the speed sensor. On the CAN bus 1, we have the GPS. When I get the second GPS, I'll stick it on CAN bus 2. And then we have a telemetry 2 feed out to the cameras. And this is where it starts getting a little bit complicated. So there's a servo feed, sorry, not a servo feed, but an RC channel feed here, which basically signals which video feed I'm going to have. So you flick the switch, it changes the PWM, this reads it and switches the camera. So I've got my 2 cameras there. It then outputs the camera to an OSD, which takes the feed from telemetry, and that shows me things like heading, shows me battery, basically anything I want from the telemetry I can display on the screen. So when I'm using the goggles or I'm flying using the screen, I've still got all my key data sets there, so I can check I'm not going to stall, I'm checking I'm at the right height, what mode I'm in and all that kind of stuff. So that's good. And obviously that feeds out to the transmitter, and that sends the signals to the ground station. So we got the telemetry antenna, we've got the video antenna, and these transmitters get pretty hot. So I've come up with a way of mounting it so that actually the passing air will cool it, and it's not actually inside the drone. Hopefully it's going to work. I think it should. It's quite an interesting way of thinking about it. Obviously, I can't fly in the rain anyway, so there's no point in protecting it from the elements. In terms of rain, obviously, you know, the wind is there to cool it down. So we'll see how that goes. And then coming down here, we have the PWM feed to the servos. Obviously, we've got 2 on the main wings for the ailerons, and then 2 for the tail. And then finally, last but no means least, we've got the receiver, which is actually a transceiver, because it sends telemetry back to the hand transmitter as well. Not much telemetry, but it sends enough. It tells me what voltage this is getting, and whether the signal rate is good. So it actually it basically keeps a track on the data packets going backwards and forwards. And if you're starting to get signal loss, it's called RSSI, starts going up. And that means that you're probably getting on the limits of range, or there's some kind of interference between the two that's affecting it. And what I have done on this receiver is I've taken these stock wires off because they weren't long enough to reach both sides of the drone. It is that big. So I've put my own wires on. These are actually coax, very, very tiny coax cables. Someone with my size hands, it was quite tricky to do. That's where the visors I was talking about with the magnifying lenses came in really, really handy, because without them, there's no way I would have done that without screwing it up. And what I've done is I've got some SMA connectors on there, and I've got some, because this is 2.4 gigahertz, I've used some SMA Wi-Fi antennas, and they are they are tuned to the right frequency, so they should be able to give me some good attenuation through them, whilst being also quite handy to mount as well. So that's how I'm going to wire. Obviously, I've got my ESCs up here going to my motors. They actually provide quite a bit of weight on the wing, so I'm glad I've got those carbon spars running through it. So let's go and have a look and see how it looks on the plane. Right then, here she is. So this is the Believer drone, all finished up. What we can see is we've got the camera and the pitot tube here at the front. We have our motors and propellers attached. I've got it up here on a little stand. We've got the video transmitter and everything all set up. So let's open it up and show you inside. So we have the battery compartment here, and I have a number of UBECs there. So I've got the 3 5-volt ones and the 112 volt. I don't have a battery alarm yet, but I will get on that one day. And then obviously got the space here for the payload. This is a spare servo lead because I haven't got the parts I need for the micro servo. And this is where it gets all a bit busy. So the flight controller installed. We have the 2 power modules there, giving us redundancy with a dual feed in there, and there will be a dual battery feed here to a common rail in the back here. We have the receiver here, and I have kind of made some antenna mounts here, and these are Wi-Fi antennas. As you can see, one is 90 degrees perpendicular to the other, which is deliberate. I'm not sure, now they say they're omnidirectional, but I'm pretty sure that they will favour one way or another, because these will be kind of zigzagging inside here, which means that there may be more bias one way or another. So I decided to put them at 90 degrees to each other. That meant taking one, as you can see just here. And what I did is I just cut through that before getting to the wire inside, obviously twisting it 90 degrees and super glue. And also, as you can see, the wiring inside, I've got a lot of clips and organisers going on, and this helps keep it nice and neat inside. So just coming all the way to the back there. I can't take it off fully. But in there I've got the connections for the servos, and I've also got the connections for the lights. As you can see, I've got the Strobon Cree light here, which is extremely bright. There was one underneath as well, but it's failed on me, so I'm going to send that back and get a replacement. Yeah, so we're all set up. Oh, I've also got my little nav lights on the ends here, which are really cool. So the 12-inch props, they are attached and balanced just about.
And I've made this stand here which allows me to attach the props and play with the motors. That was a really important actually, because what I didn't realise is I got a lot of vibration out of this this propeller, and I couldn't really figure it out. And then eventually I realised that these screws here that attach this to the motor had come loose. So tightening those up got rid of the excess vibration, and that's all great. So I've got the screen here, the video receiver, which the antenna's a bit loose. Tighten that up, and then I've got the controller, and inside I've got my computer with the mission planner on it. So what we're going to do is I'm just going to fire it up, and then we are going to see her in action. Okay, so let's connect to the battery. So how do you switch it on? Obviously you get this beeping noise from the ESCs. That's to tell you there's no PWM signal coming in. The Ep3 GPS starts initializing, so the red and blue flashing means it's getting ready. The flashing yellow means that it's got a signal but it's not ready to arm. And then I've got the safety switch here, which flashing means that the servos are switched off, which means obviously the motors are switched off, which is why they're beeping. So if I turn on the controller, so there's the beep. That lets me know the receiver is being, or the transmitter is being received. So there we go, safety on. So I'll turn it off again for a second. There's that succession of beeps. That was the ready to arm signal. So let's put all this on. Rearm. So there's two ways of arming really. You can either do it directly in Mission Planner, or I've got it set up so that I just do that for a couple of seconds, and that lets you know, that beep lets you know that it's armed. As you can see, we've got juice going to the propellers. So let me just put the controller on properly, and we'll give you a demo. So that's about 25% power. I'm not going to go full because it does run the risk of running off of the stand here. But yep, we got full movement here, and I can switch between the flight modes. Also, what you can see, hopefully, is the video feed. Now, I've also got it set up with a rear camera, and I can switch between the two. So there we go. That's so green flashing means it's ready to arm. There we go. Switched off. So I'm just going to power it down. So yeah, just a few things to note here is that the organisation of all of these cables took a long time. So like I told you, I went for the making my own twisted servo cables. So what I would recommend you do is you start from one end to the other. So you make your connection on one end, you fit it, you start routing the cable, and then you know exactly how long you need it to be when you get to the end. Otherwise, what you'll find is you're going to waste a lot of time making a cable you think is the right size, fitting it. It's either too short or it's too long, and then you have to either remake the cable or redo half of it, which is just a bit of a ball ache, really. So yeah, as you can see, I mean, there's still loads of space there in the payload bay. I've got some ideas for that. But yeah, we're going to be flying very soon. So Boris Johnson laid out his plan, and we have a green light to do recreation again from the 8th of March, which is unfortunately 4 days after this episode will air. So I shall have to do a separate kind of flying session for that. Keep your eyes peeled on the Twitter, because and on the channel in Discord, because that's where I'll announce it all. So the next episode we'll be talking more about the regulations. So I might do the flight after I've done that, because it's the natural progression. You learn the law before you fly, obviously.
To wrap up that monster episode, I just want to go through a few things. So the first thing is, obviously, the build of the electronics was a much bigger job than I had anticipated. Partly because of the of routing all of the wires that needed to be done, and I started using the wires in the kit, and I realized that I didn't, I realized I wanted to go down the twisted servo wire route to avoid any kind of interference from RF. So I had to restart all the wiring again, basically, and then making my own cables from scratch. So that took a lot longer than I thought it was going to. And actually, another problem I had, which really ate up a lot of time, was problems I had with Mission Planner. And I'm not going to go into using Mission Planner here. It's just too much. I could easily do a 3-hour session on Mission Planner and just scratch the surface. There is so much to learn there, and there's so much to get across that I'm not going to be able to do it justice. And there are lots of videos out there already about Mission Planner, how to do this, how to do that. I'm probably going to cover some basic ones that I'm going to be using, some of my flights, my test flights, and all that kind of stuff. But I'm not going to go into the detail of Mission Planner. Like I said, there's just too much there to do in a short episode like this. One thing I will say is, make sure you use the right drivers for your telemetry unit. So it's basically a USB serial port, and you have to get the correct drivers. Because one of the problems I had was Mission Planner would work fine, and then one day the telemetry would go weird. So what I was doing was I was losing part of the GPS data feed from the CAN bus, and it was weird because I was still getting GPS time, but I was getting no GPS satellite locks. I was getting no GPS data, but I was getting the time, so the GPS was still there, it was still working, and I couldn't figure it out. And it wasn't until I basically had read up online that someone had a similar problem. They wiped everything and reinstalled, and that fixed it. Well, it didn't fix it for me. It wasn't until I went to a second computer and I installed it there with the correct drivers, and bam, it all worked. It worked so well that I was kind of frustrated with myself for not realizing that actually some of the stuff that I was seeing was not me. It wasn't the electronics. It was actually the bad drivers. So absolutely make sure you get the right drivers for your telemetry unit. And if you stop before you install them, and absolutely doubly make sure that they're the right ones. Because there's no going back. They really do kind of screw things up. So, like I said, I'm going to be flying as soon as I can. On Monday, after this episode flies, that's when we can do recreation again outdoors. And actually, I can do it with one other person, not in my household. So I've got a friend who said he's going to come and help me launch, because really launching a drone this big is a 2-man job, and he's going to help me out. He's also quite interested in drones and their capabilities, not from a cybersecurity side, but more for geospatial intelligence. I'm hoping he's going to maybe lend me one day a really nice, snazzy multispectral camera that we can do some really cool work with, but that's further down the line, and that's for another episode. Speaking of episodes, the next one, regulations. So regulations are important. They are updating all the time, and actually there's been a recent change to not just the CAA but the FAA regulations as well. I've also just read about a commercially available drone which got BVLOS approval through the CAA, and I'm going to talk about that too. But the really exciting thing about the next episode is that I've been speaking to the CAA, and they have very kindly, graciously agreed to come and talk a little bit on the next episode. So I'm going to be sending them some questions. I'm going to talk a bit about CAP 722, which you've heard me talk a lot about. I'm really excited about it. I think it's an amazing step forward for drones in the UK, and I think it's an excellent, lighting of the pathway for other regulatory bodies to really look at and follow. I think that's my personal view, but and they said they're going to come on and answer some questions on the next episode. They've also agreed, if you want to send your questions in, if you've got any burning questions for the CAA about drones and regulations, send them in, and we will ask the CAA when they come on board. So that's going to be really, really cool. So as always, don't forget we have the Q&A in the Discord channel. I'll be there for as long as I can stay awake, because it's obviously quite late here in the UK. The URL, the link to the Discord channel is in the link to the video here, but I've decided to put in a little bit of a QR code here, if you trust me with the QR code. And that will take you to the Discord channel as well. As always, please stay safe. We're coming to the end of the tunnel. The light is there. We're heading towards it, and we're going to get out of this crazy madness and actually try and get some kind of normality going forward. I should hopefully keep you entertained with some videos of flying. I'll probably do a video of my training as well. I've got a little trainer aircraft which I like bashing up in accidents, but that's what trainers are there for. They're there to crash, so you don't crash the big ones like the Believer there. And also, actually, last one, what name should I give her? I haven't given her a name yet. I've got my, as per the CA regulation, I've got to have my operator ID. I've got to have the drone ID on there as well, but she needs a name. So send me your ideas in for the names. The best ones, I'll put in a poll on Twitter, and we'll see, which one wins. And you never know. There might even be something special for the guy or girl that proposes the best name that gets chosen. All right. Like I said, stay safe, and I hope to see you guys soon.